Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework for yesterday. Multiplication using generic rectangles. This is another strategy that is going to come in handy when you get into high school math and we replace the problem of 46 times 67 with a problem like x plus 2 times 3x minus 1. This generic rectangle is going to come in very handy when solving a problem like that. But just to make sure we understand how all of this works, this is really a way to show how the algorithm works. When you're taking 67 times 46, the multiplication algorithm says multiply the 7 times the 6 first, and you would get 42 for an answer. And some people, like when I was younger, I learned to carry the 4 over to the next column, but we could just write the 42 here if we want and create 4 different rows of products. Then we go to 40 times 7, which is 280, and that would be written here. And then we do the, oh no, I did it out of order. How about 6 times 60? That's this number right there. And then 40 times 60 is 2,400, and then you add all of those together to get your total product. So this is kind of a way of showing that when you multiply these numbers together, you're not multiplying like the 6 times the 4, the 7 times the 6, and the 4 times the 7, and blah, blah, blah. This 6 has a value of 60. That 4 has a value of 40. So by setting up the generic rectangle for multiplication, you get to see the values of those numbers and their products. So that being the case, 54 times 32, you know that 30 plus 2 is 32, and 50 plus 4 is 54, so we can multiply the 30 times the 50, the 30 times the 4, the 2 times the 50, and the 2 times the 4, and then add all of those together for our final product. Same thing with the 91 times 78, 90 plus 1, 70 plus 8. Here are the individual products. Find the total sum, and that's the total product of 91 times 78. And if you were ever like doubtful that that was true, well, go ahead and show it on your calculator. 91 times 78, oops, I hit it twice, is 7,098. That's what we got right there. Here for Cecil, I love Cecil. I love these lessons, helping students understand what it means to add and subtract numbers, and eventually what we do when we add and subtract negative numbers with positive numbers. So picture a span, a tightrope of 6 feet, and these are the given lengths. So how could Cecil get across? Well, there are lots of different combinations that would work. You could just do 1 step of 4 feet and 2 steps of 1, or since the rules of Cecil allow you to go past the tightrope and then back your way back to the end point, here 4 plus 3 is 7, and then you have to back up 1 foot to get to the 6 feet mark. So go ahead and take a look and see what I have in there. You probably have something completely different because there are an infinite number of combinations that you could use for these different steps to get any given length. And now we're going to kind of use the same process, but we're not really thinking of it in terms of a tightrope. So 5 plus 2 plus 8, these are all positive. So that would be like starting at one point and crossing over. And so if these were your 3 steps to get to the end, the tightrope must be 15 feet long. Here they would be 16 feet. Here you got 10, 12, but then you got to back up 4 feet to get you to 8 feet. And here you got 8 and 6 makes 14, 15, 16. But now you're going to back up. So you went from 16, and then you backed up 5 feet to get to 11. If I'm going quickly, once again, you know what to do. Go ahead and pause the video, and you can make your corrections if you need to. Here we've got number lines, and so here you got 1, 2 steps to get 20 total centimeters. So that means that every step must be 10 centimeters. So 10, 20, 30, 40, 50. Here you've got 1, 2, 3, 4 steps to get 32.4 centimeters. That means that every one of these steps is 8.1, 16.2, 24.3, 32.4, and so on. Here you're going 1, 2, 3, 4 steps. You go 8.8 minutes. So how many minutes per step? Divide it by 4, and you get 2.2 minutes per step. And then here you're going 1, 2, 3 steps to go 10 minutes. And so that's going to be, what is that, 10 divided by 3. You could have said, no, that's not 6, it's 3. You could have done it as a repeating decimal of 3.3 repeated. So this is 6.6 repeated, and then 9.9 repeated, which is the same thing as 10. So there you go for scaling, and make sure, you know, the process. How far did you go and how many steps did it take you to get there, to figure out the unit rate, which would be the distance per step. One of the topics you will review in this course is reading graphs. Look at the graph at the right. This graph shows positive and negative values on both axes, right? Here's your x-axis, counting by ones going in the positive direction and in the negative direction. Also on the y-axis, the same exact counting sequence. So what happens here is your coordinate grid is broken up into 4 equal sections, and so it's 4 quadrants. Technically, this is quadrant number 1, number 2, number 3, and number 4. Oops, number 4. This is quadrant number 1 because this is the quadrant where all numbers are positives, and that's where we do most of our work. The rest of them, you know, we decided to label it going in this direction. All right, so the coordinates of x and y values for point A are -3, 5. So here you got -3 for the x value and the 5 for the y value. All of these coordinates are xy coordinates, so you want to find wherever your point is, how does that align with the number on your x-axis? This vertical, I guess it's vertical alignment with the -3, so that means that's going to be -3 here, and this lines up with the 5 horizontally. So the x is -3, the y is +5. So name the coordinates of points B and C. Well, this point here is where x is equal to -5 and y is equal to -5. This point here is where x is equal to 3 and y is equal to about -4. Okay? Oh, wait, no, I'm doing C, not A. So C is where x is 4 and y is -2. So then it says Samantha moved point A 9 units down and 6 units to the right. So if you went 9 units down, it would go 1, 2, 3, 4, 5 just to get to the x-axis. Then another 4 units takes you to the -4. And then 6 units to the right, it's going to take 3 to get to the y-axis and another 3 to get to where x is equal to 3. So that ends up being the point after moving point A from its original location to its new location. Is that it for this particular problem? That is it. Okay. Gracie loves to talk on the phone, but her parents decided to limit the amount of time she talks. They decided to keep a record of the number of minutes that she spends on the phone each day, and here is the data. Now, you notice there are 3 days where she didn't talk at all. That has to be factored into the averages, right? You can't just take the high numbers and not take also the low numbers. She needs to be given credit for the days when she didn't spend any time on the phone at all. So it sort of balances out a couple of these marathon phone call messages. What's the word I'm looking for? Whatever, when she was talking a lot on the phone, okay? So find the mean and the median. The mean, you add up all the numbers and divide by the number of numbers. So the total sum of all these numbers is 255 total minutes, and they collected data for 9 days, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So you take the total sum, divide it by 9, and you see that the mean is 28.3 minutes per call. The median requires you to put the numbers in order from least to greatest. So with the median, you got 0, 0, 0, 10, 15, 20, 30, 60, 120. And because there's an odd number of numbers, the one in the middle will be the median. There won't have 2 in the middle for this one. And so the median is 15. So which one appears to be the better average? I know Gracie would like to say, take the median, because that proves that I'm only talking for about 15 minutes per day. And the parents are like, yeah, but the mean is 28. That's almost twice as much. How can they be so far apart if they're both measures of central tendency? Well, here's your answer. The fact that the 120-minute call was an outlier. If you remove that outlier from here and from here, you would see that the mean and the median come relatively close to each other. With the outlier in there, you could change that to 60 and the median would still be 15. But if you changed it to 60 here, that would affect the total. In fact, I'm going to check and see what that would end up being. If I took that total, which is 255, 255, and then took away 60 from it, so the 120 became a 60 instead. Now it's 195 divided by 9, and now you get much closer. So the difference between 21 and 2/3 minutes and 15 is much less, well, a little bit less at any rate. But still, because you had an outlier here, it's better to go with the median than it is to go with the mean. And that ends our homework session for today. All right, go ahead over to today's lesson. Sorry, I've got hiccups. And get started on today's lesson. Take care. Bye.
Hey, feeling good, like I should. When